Hello everyone, my name is Samuel Esong and welcome back to my YouTube channel. This is the next video in the DevOps playlist and today we'll be looking at Docker environment variables, Docker networks and Docker volumes. So just like in my previous videos, I am teaching you how to think like a DevOps engineer. For every topic in this video, we will always start with the why before we move into practical because this is very important. Again, if this is your first time in my channel, my name is Samuel Lesson. So please, I would love you to subscribe to my channel, like this video, share this video with your friends, and comment on this video. So we are going to cover environment variable, then we'll also look at Docker networks, then we will also look at Docker volumes. Now, for the first part, environment variables. All right, so before containers, most applications were configured using configuration files on servers. All right, or you can simply say values were hard coded into the application. Now, this approach does not work well in containerized environments. This is because in containers, all right, your image is immutable. Your image is immutable. What I mean by immutable is the same image may or must run in development, staging, and production environments. All right. So the best way and a correct way to pass configuration is mostly at runtime. So this is exactly why environment variable exists. All right. So we use environment variables to pass um, things like database username, things like API endpoint, things like database host. You can also use environment variable to pass things like passwords. So if the term variable is very new to you, you can see variable as a placeholder for values. All right. Now, if I say car is equals to 3, I am simply saying that you can substitute 3 or you can substitute car, all right, for 3, or car is a placeholder for 3. All right, so car is the variable name and 3 is the value. All right, so let us see how this works out in practical. So I'll bring up my terminal and so I am going to interact with a very simple Docker image called BusyBox. So we are not really going into in-depth. All right, so I will do Docker run. Docker run. All right, because I want to run this with or after Docker runs, I need an interactive terminal. So I'll add iPhone IT, then I'll also combine with iPhone RM so that when I exit from the terminal, all right, Docker will automatically stop the container and also remove it. All right. So then we use the iPhone E flag. All right. So the iPhone E is used to pass a variable. All right. So let me say that if the variable name is app name and what is the value, then I can say school. It'll be something like this: school system. All right, let me pass another variable. So I'll say app. Okay, I think this is okay. All right. Then the image name, I will use busybox. Then of course sh. So sh is going to give me a bash shell. All right. So if I hit enter, then all right. So I am now inside my container. All right. Remember that we passed the variable name, app name, and also app environment. All right. So let me echo. If I echo app name, if I echo app name, I should see school system. And if I also echo app env, I should see production. So in essence, since the busybox image is immutable, all right, so I can also start the busybox with another variable. The image still remains, but if I'm running the container, I can inject another variable, all right, in busybox. All right. So guys, what I want you to understand here is very simple. The image did not change, the code did not change, only the runtime configuration changed. All right, so this is the correct way to pass variables. Don't hard code your variable during the build time. So now that we understand what a variable is and how to pass variable at runtime, all right, then let us look at Docker networks. So understand that real applications are not single containers. All right, real applications are not single containers. Most of the applications you will be containerizing and you'll be working on are not just one containers. So we normally have things like the front end. All right, we also have things like the back end, a database. Some applications may even have things like background workers. All right, things like the messaging queue, etc, etc. Now all these services must communicate with one another. All right, now the problem is containers are created and destroyed frequently, and of course IP changes. That is, the IP addresses of these containers changes whenever they are stopped and restarted. Now, Docker networks solve two important problems. The very first one is connectivity. The second problem Docker network solve is service discovery. Now, Docker networks also aid to provide isolation. Now, let us look at the types of network we have. Now, the very first type of Docker network we have is the bridge network. This is the most common type of the Docker network. All right, whenever you create a container, the bridge network is created by default. All right, so this is the most common used network type on a single host. So it allows communication, or yeah, it allows containers to communicate with each other on the same machine. So when you create your own bridge network, of course, Docker automatically provides a DNS. All right. So the DNS is what we will be using and not the IP address. So another type of network you will likely see is the host network. All right. The host network. So in this type of network configuration, the containers running on your infrastructure uses the host network directly. That is, there is no network isolation. Now, this particular configuration is rarely used and should be avoided in most cases. Another network type is the non-network. That is, containers has no network at all. So this can only be used for very special and isolated workloads. All right. So another type of network we may likely see is the overlay network. So the overlay network is used for multi-host container communication, such as Docker Swarm, and of course, this is what Kubernetes also use, the overlay network. So let us see how to create networks in practical. So to create a network, we'll use the command Docker network. Let me expand this. All right. Docker network create. Let us call it test network. All right. Docker network create test network. So if I hit enter, my test network has been created. Let us view the network we have. We use Docker network ls. So this is going to list the network we have. So we have the bridge network, which is the default network. All right. The host network. All right. So this is also a custom network I created. We can also see the non-network we talked about, and then the test network we just created. So note that whenever you create a network, you are also creating a bridge network. All right. Just that your network is isolated. All right. So now let us run a container with our test network. So we do docker run. I'll run it in the detached mode. I'll call this test one. All right. Hyphen network. What is the name of our network? Test network. All right. Then let me run a simple Nginx container. All right. So I'm going to create 3 networks, or 2 networks rather. So I'll still call this, I'm going to create 2 containers. All right. So I'm going to call this test2. I'll call the second container test2, and I will also run it with the Nginx image. All right. So let us do Docker PS. If I do Docker PS, I can see these 2 guys running. So let me go into test1 and ping test2 from test1. All right. So I'll do docker exec -it test1 then sh. All right, so ping, remember that containers are ephemeral in nature, what we talked about already. All right, so I am pinging test2, that is this container here. If you notice, I am not pinging with the IP address. Instead, I am pinging it with the container name. All right, so I am pinging with the container name. Remember that Docker Network also helps us to, or also helps with service discovery. All right, so this DNS is going to automatically convert to an IP address. All right, so if I do ping test2, unfortunately ping is not installed in my container, so let me quickly install ping. So apt update, so we'll give it a second to finish patching the server, or the container rather. All right, so I'm going to install ping with apt install iputils ping. Let us do that again. Apt install iputils ping. All right. All right, so I can now do ping test2. So there are a bunch of replies from test2, meaning that where we are, the test1 container can reach test2, and test2 can also reach test1. All right, guys. We have seen that containers communicate using containers or service names and not IP addresses or local host. Now let us move on to the next topic, Docker volumes. So what is a Docker volume? So you can simply put it this way, that a Docker volume is a directory that lives outside the container file system, but it is mounted into the container at runtime. So what I mean is that the container sees the volume like a normal folder, but the data actually lives on the host. So what you need to understand is that Docker volume separates container lifecycle from data lifecycle. All right, Docker volume separates container lifecycle from the data lifecycle. Now let us consider the type of mounts we have in Docker. So at a very high level, Docker supports one, the volume mount. All right. So this guy is managed by Docker. Then then we also have another type of mount called the bind mount. All right. So this is the direct host path. All right. So we are going to focus. Let us focus on the first one first. Then I will explain what this is all about. So back to our terminal. Let me clear this. So I'm going to use a very simple Nginx container so that we'll get to understand volume very well. So let me run Docker run in the detached mode. I'll give it a name. Then I can say volume test. All right. Then -p. Then let me use a simple Nginx image. All right. So if I come to my browser and do localhost, all right, 8081. Second, guys, Docker PS. Okay. Let me open this in an incognito mode. Localhost 8081. All right. So I can see welcome to Nginx here. Now let us modify this document here. All right. So to modify this document, I'll simply go into the volume test container. All right. So Docker exec -it, the name of the container, volume test. All right. Then sh. All right. So the default Nginx web root in a container is located at /user/share/nginx/html. So that is where we can find the index.html page. All right. So I'm simply going to echo practicing volume. All right. Then I'll take this to /user/share/nginx/index.html. All right. So if I exit this container, then all right. So I have modified the contents of this volume. Let us stop this container and confirm if this document or if this index.html file is going to persist. All right. So I will come here and do docker stop. Docker stop. The name of our volume is volume test. All right. Volume test. If I do docker ps, of course, our container is not here again. All right. So let me remove the container. So Docker rm. Let me also remove the stop container, volume test. All right. So if I come back to my browser, this is not reachable again, meaning the container is not accessible again. All right. So let us start the container again. All right. If I reload this guy, you will see that the data we had, which was the practicing volume, I think, has been replaced with the default Nginx page. All right, so let us make our practicing volume data persist. So this is where volume comes in, because we have modified the file inside that container and it disappears when the container is removed. So we are going to run that same container with a volume. First, let us create a volume. Let me stop this. All right. So to create a volume, we simply do docker volume create, then I'll call it test volume. All right. Now let us run that same container with this volume. All right. So I'm going to add the -v flag here for volume. Then what is the name of our volume? Test volume. All right. Where should I mount it? I'm going to mount the volume inside the container, and I'm going to mount it in the /user/share/nginx/html path. All right. So if I hit enter, all right, then let me exec to confirm. All right, so this is what we have now. All right, so let me modify let us exec into the container and modify the content of that nginx file. All right, so docker exec -it. What is the name of the container? Volume test. All right, volume test. All right, so I'm going to repeat echo hello from docker volume. All right, /user/share/nginx/html, then /index.html. Sorry guys, there's a mistake here. So echo hello from docker volume, all right, to /user, made a mistake with user, /share/nginx/html, then /index.html. All right, so if I reload this guy, then I should see hello from docker volume. So let us stop this container from running. If I do exit, so if I do docker stop, all right, then let me also remove the container. All right, So if I reload this guy, I should see unable to connect because our container is no longer running. All right, so let me start the Nginx container with the volume we created, which is this guy. All right, so if I hit enter, then we should see our content again. So if I upload this, so we see our content. All right, so this is the most important thing to understand about volumes, that volumes helps data to persist. All right, so when you are containerizing your database and serving it in production, make sure that you add a volume to your database. All right, because whenever if your database does not have a volume attached, note that a user's data will be lost whenever that database container stops and restarts. So now let us inspect our volume. To inspect our volume, we simply do docker volume inspect the name of the volume, which is test volume. All right, so this is going to show us where Docker stores it on the disk. All right, this is our mount point /var /lib /docker volume /test volume, then the data. All right, it's also going to show us the driver and the mount option. Then we talked about bind mount. All right, so instead of a Docker managed volume, maybe you want to mount a host directory. All right, maybe for example, during development, you can make your container to directly read your local file. All right, so but note that in production, volumes are always preferred. For instance, let me create a directory in my home directory. Yes, let me create a directory in my home directory. All right, so I'll simply say site. All right, so let me mount um, so I'm going to, for bind mounts, all right, for bind mounts, I am going to edit the Docker volume we created. All right, note that I have created a folder named site on my local machine. All right, so what I'm simply going to do is I'm going to bind the content of this guy to the folder on my local machine. All right, so I'll do pwd, that is to print working directory, and the name of the folder, which is site. All right, so if I hit enter, okay, so let us run this with a different container, because the volume test container is already using the test volume we created. So I'll change this to bind mount. All right. All right. So okay, I also have another error here because of this port. So let us change the port to 8083 because there's a container running already on 8081. All right. So if I hit enter, all right. So this should go through. All right, guys. So if I want to reuse this guy now, this method is purely for development. This method should not go into production because let's assume there is an attack on your local machine. All right, automatically, if the attacker should get hold of, if the attacker should get hold of the site directory created, all right, then the attacker will definitely um, um, see if it was a database, and the attacker will definitely gain access to our database. So make sure that your database, make sure that you are storing your database data with a volume. All right, because if you store database data without a volume, you will definitely lose data. We've talked about this. All right, and understand that volumes are not part of images. All right, and don't mount over important parts unintentionally. All right, so these are the three mistakes you should not make. So guys, if this video helped you, please don't fail to subscribe to my channel and drop a comment, and also share this video with your friends. In the next video, we are going to talk about Docker Compose, and we are also going to see how we bring everything we've learned on Docker together to give us a real application. I'll see you on the next one.